The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so I'm going to work through problem number 18 for Physics 2020 Midterm Exam 1, the year 2010. And in this problem it says, in the Tour de Georgia, the riders climb Brasstown Bald, starting at an elevation of 2,000 feet and ending at an elevation of 4,500 feet. The distance traveled on the road is 10 miles, and if a biker has a mass of 65 kilograms, what is his change in potential energy? So basically here is a illustration of the problem statement where we have some sort of hill or mountain that's located in Brasstown Bald, Georgia. That's located in Georgia. It's called Brasstown Bald. We have a biker who is starting at an elevation, so the initial height is going to be 2,000 feet, and they're going to be basically traveling along this hill or mountain, and not necessarily going straight up the mountain, but it may curve around, and until they reach an elevation of 4,500 feet. All right, and they say that the total distance that this biker travels is 10 miles. And so this problem is asking us to find the change in potential energy. All right, and so one of the things that I guess this problem is trying to get you to understand is that potential energy is a state function. Okay, a state function means that it's independent of path, and so we have there's a lot of different types of energy. There's kinetic energy, heat energy, potential energy, potential energy, if you look on your formula sheet, okay, under conservation of energy, we denote the potential energy with a U, and we define it as the mass times the acceleration due to gravity times your height, your vertical height. All right, and so the change in potential energy would just be your mass times, it'd be your final potential energy minus your initial potential energy. Change is always defined as final minus initial. So it would be, since your mass and gravity doesn't change, those are the same in both cases. The only thing that's changing is the height, okay? So the change in potential energy basically can be defined as mg times the difference between your height, which is also equal to, okay, if we define your final height minus your initial height as just as delta H, which is your change in height. So this would be the equation for the change in potential energy. Now, the reason why the change in potential energy is just defined as your difference between the elevation, or your height, times the mass and gravity, is because, like I said earlier, it's a state function. So the fact that they gave us this information about you traveling 10 miles is irrelevant, okay? The only thing that's of any significance is the difference in height that you travel, okay? It's independent of a path, because potential energy is a state function, all right? So we have basically this information that's given. We can substitute that this information into our equation when we know that the mass is 65 kilograms, all right? So we know that delta U, change in potential energy, is going to be your mass, which is 65 kilograms. Oh, almost forgot. Before we do that, we've got to do some things. We've got to basically do some unit conversions here. Why do we have to do unit conversions? Because, well, if you look at the answers, okay, for this problem, everything is given, well, the answers are given in joules, megajoules, joules, and watts, okay? Watts is basically, so everything is going to be converted into some sort of SI unit other than watts. So then we need to basically convert this English unit feet into the SI unit, which is meters, okay? And so that's what we need to do first. We need to do unit conversions. So let's do that. So we can say that the initial height, which is 2,000 feet, and if we look on our review sheet, we'll see that there are, for every meter, there's 3.28 feet, okay? So this works out to be 609.756 meters. And if we do the same thing for the final height, that works out to be 1,371. All right, and so these are our heights for our starting and our finishing heights in metric units. So now we can substitute into the equation. So the change in potential energy is 65 kilograms multiplied by 9.8 meters per second squared times delta H, which is your final H, which is 1371.95 minus 609.756, and that is in meters. All right, and what you'll see is that you'll have kilograms times meters and another meter, so that's kilograms. So you'll have kilograms put the units here. You'll have a kilograms meters squared per second squared, and that is what we call a joule, okay, or J. All right, and so the change in potential energy actually is, when you work that out, do the calculations, you get 485,517 joules, and so we look on our answer sheet. All right, for number 18, we don't have anything that fits that that answer, but we do have 485 kilojoules. So if we basically now convert this, we can simply multiply this answer. We know that there are 1,000 joules in 1 kilojoule. Okay, so we're going to multiply this answer so that the joules cancel out and we're left with just kilojoules. So essentially we're just dividing the answer by 1,000. So that leaves us with approximately 485,000 kilojoules. I'm sorry, 485 kilojoules. All right, so that is the answer, 485 kilojoules. Again, the critical piece of information that we needed to know, that you need to know in order to solve this problem, is that potential energy is a state function. It's independent of path. And so all we needed to do was find the difference in elevation, and we were able to use this equation to solve the problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.